Good morning, good afternoon, or good evening. Welcome to A Level and AP Physics. In today's lesson, we will discuss past paper questions from May June 2025, Paper 2, Variant 1. As always, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 1 part A says define acceleration. So acceleration simply is equal to the change in velocity over time. So we can say delta V over delta T. So we can define acceleration is the rate of change of velocity. So simply we can write down acceleration is rate of change of velocity. So this is how we can define rate of change of velocity. Part B says in an experiment, two objects A and B are released from the side of a building as shown in figure 1.1. Object A is released from rest at a height of 14 meters above the horizontal ground, mean it is released from this point. Then the height of this one is equal to 14 meters. Object B is released with an initial upward vertical velocity u at a height of 3.6 meters above the ground. So B is released from this point. Both objects take the same time to reach the ground and they do not collide with each other. Air resistance is negligible. For part B1, we need to calculate the time taken for object A to reach the ground. Means how long it will take to start from here and to reach the ground, and it is released. So release means that initial velocity of this one is equal to 0, as in this case there is no air resistance, so acceleration of this one is constant and acceleration of this one will be equal to g. As acceleration is constant, we can use SWOT equations. So simply we can use s is equal to ut plus 1/2 at square. In this case, u is equal to 0. So u is equal to 0. So we can say s in this case will be equal to 1/2 gt square. We are taking in this case down is positive. So we are taking downwards as positive. As we are taking downwards positive, so it means s is positive, g is also positive. So now we can simplify this one for the time. So we can say t square will be equal to 2s divided by g. From here we can say t will be equal to 2s divided by g square root of this. Now simply we need to plug in values. Vertical displacement is equal to 14 meters and value of g is 9.81. So if we solve this one, we will get about 1.69. So this is equal to 1.7 up to 2 SF. So our final answer we can say is 1.7 seconds. Second part says use the answer in B1 to calculate u. So use your answer in B1. It means this is very important information. So this is kind of hint for you, and also you have to follow this hint. So in the last part we have found the value of time that was equal to 1.689 seconds. Precise value means more than 2 SF. You have to use the exact value from the last part, not after rounding off. So before rounding off, that value you have to use. So that value was 1.689. Now we need to understand the motion of the beam. So what do we have in this case? We have the u that we need to calculate is upward, and we have the vertical displacement. So this is the vertical displacement. You have to be very clear. So what is the displacement from this position? So this is the vertical displacement, and this is in downward direction. So downward direction, and t we have, u we have, and in this case acceleration that is equal to g, and this is equal to 9.81 meters per second, and acceleration is also in downward direction. So we can also write on s, vertical displacement, this is equal to 3.6 meters. This is also in downward direction. So we need to find u. So this is what you need to find out. And so how we can find out this value of u. To find the value of u, we can simply use s is equal to ut plus 1/2 gt square, and in this case we will take down is positive, so we are taking downwards is positive, so it means this value will be positive, this value also will be positive. Now simply we can plug in values. So what is value of s in this case? S is equal to 3.6, so this is positive. U we don't know, but we have the value of time, that is 1.689, so here we have 1/2. G is equal to 9.81, and this is positive 9.81, and here we have t square. Now simply we can write down this is 3.6, so here we have 1.689 times u, plus we have 4.9, so we can simplify. So this is 4.9, means 9.81 divided by 2, so we can take this is 4.9, and the value of t is 1.689 square. We need to solve for u. So simply this term we can take on the right side, so let me write down here. So we can say in this case 1.689 u, this will be equal to 3.6 minus, we will get 4.9, so you can use precise value 9.81 divided by 2. I'm just using this simplified. So here we have 1.689 square. But if we solve this one for u, we will get u is equal to minus 6.2 meters per second. So what this negative sign is telling us, up to 2SF we have this one. Negative sign is telling us direction of u is opposite to this. So it means u is upwards, mean the initial direction of initial velocity is upwards. So this is what negative sign is telling us, mean is in opposite direction of our assumed direction. We assume we have taken down positive, we got negative answer, it means initially u is in upward direction. So this is significance of negative signs, and this is how you can answer. Part C says, in the second experiment, object B is released from the same height and given the same initial speed as in B, but at a release angle theta to the vertical as shown in figure 1.2. State and explain whether the time taken for object B to reach the ground is less than, the same as, or greater than the time in B1. Little bit tricky question, but how we can answer this question? First of all, the object was released vertically upwards, so it will go up. So what was the initial vertical velocity when we release this one upwards? So we can say u initial was equal to u. Now how about in this case? So in this case, the vertical component of the velocity, so let me redraw here. Now we release this one at certain angle. This one is u, and it is given to us. This angle is theta. So we can resolve this one into two components. So we can resolve into two components. So one component is horizontal, and one component of this velocity is vertical. And this new vertical component, this will be equal to u cosine of theta. This will be u cosine of theta. As the angle is greater than 0, it means it is smaller than u. So we can say u cosine of theta, this is smaller than u, because theta is greater than 0. So this is the point. So the vertical component of velocity is smaller. As vertical component of velocity is smaller, so the time it will take to reach the top where its vertical velocity component will be 0, that height will be small. So this, when we launch from here, this will go somewhat like this. So you can also draw this one, and this one will go up it will reach higher height and then it will fall. Now the time taken from this point to this point is longer, so we can say t1, let's say this is t1, and the time taken from here to here, let's say this time is t2. So t1 will be greater than t2. Now we can also look at this point here. Vertical component of velocity is equal to 0, uv 0, and at this point uv is also 0. So the time taken from here to the ground, let's say that time is t3, and time taken from here to the ground, let's say that is t4. So in this case t3 still will be greater than t4. So what does it mean? It means it will take less time than before when it was thrown vertically upwards, because its vertical height has decreased. Vertical height decreased. Why vertical height decreased? Because vertical component of velocity, this is the important point, vertical component of velocity has been decreased. So less time, so we will say less time because vertical component of velocity has been decreased. So these are the points you need to understand. I hope you have understanding now. So in the answer you have to consider these points. So you can say, first thing you need to say is less than the time will be. Then you need to say the initial vertical component of the velocity is smaller. Therefore, it takes less time to decelerate to zero vertical velocity, as we have discussed. T1 is greater than T2, means T2 is less than T1, and then accelerate downwards to the ground. Again, it will take less time, as we discussed. T4 is less than T3. So this is how you need to answer. Now let's go to the second part. Second part is saying, by considering energy state and explain the effect of the change in release angle on the speed at which B reaches the ground. Very nice question, little bit tricky. Often students, they have confusion with this one. Now let me explain you this one. I will be cleaning this part. So I will be cleaning this part to explain you this. Now simply we can take, in this case, we are looking at this point. We are looking at this point. Let me use different color for better understanding. So at this point we need to understand it has initial kinetic energy. So we can say kinetic energy initial plus it has initial GPE. So it doesn't matter we throw this way, we throw this way. Because speed is the same, so the initial kinetic energy the same, initial height is the same, so initial GPE is also the same. As there is no air resistance, so when they reach at this point, so the final kinetic energy plus final GPE again will be the same for both of them. So potential energy at this point, if we take this over reference line, so the kinetic energy final has to be equal to, this will be 0 then, if we are taking this is reference line, this will be equal to kinetic energy initial plus it has to be equal to GPE initial. So in both cases, as mechanical energy is conserved, it means speed will be the same. It doesn't matter, we throw this ball up, we throw at an angle, when it reach the ground, by conservation of energy, speed will be the same, because energy is conserved. Now let me show you the answer, how you can write down a nice answer. So this is how you can say, first thing you need to say, speed will be the same. So this is the key point. Second thing you need to say is that total initial energy is the same in these two cases, and change in potential energy is also the same. So the kinetic energy also is the same. So final speed is the same.